I'll tell you when.
All right.
Hold on. Okay.
So welcome back, and this is the second round of the short presentations of the musical works from the online music exhibit, which you can find on the main conference web page on the main menu. So now it's time to hear presentations from the remaining four. We don't have question rounds for this session, but you can feel free to use the Slack music exhibit channel to discuss the work. The composers from this morning have already answered some questions there, and Oded even posted his score for notes to his future self. So that's a good forum for that. And now for the presentations, beginning with Mr. Alvaro Lopez.
Myself, there you are. All right, hello everyone. Yeah, so let me see, I can share my screen. So the piece that I sent is made by a max patch, basically. That well, it's like a system of agents in some way. It's not using machine learning right now. It's using purely algorithmic procedures with some stochastic like methods that allow for some variation and a little bit of human feeling or stuff like that. Maybe if you see that or whenever you hear that, you will see what I'm talking about. I am going to, well, let me first share my screen, and then I can show you something interesting. So the thing is that I evolved that patch that I use for the particular piece that I showed or that I sent, excuse me, the submission, and now it includes some percussion. So there's a third agent. Before it was just an agent that does the melody, an agent for harmony, and now there is another agent for percussion. And then there is an entire system for controlling all the parameters from these agents. So let me show you what I'm talking about. Right, so the previous one, let's see if I can show you this one. This is the one that I submitted. If you notice here, let's see, I'm gonna maximize it. And then I'm gonna show you a couple of things from this one. So, wait a second. So, I can do that, well, okay. So, this first agent that says melody was in charge of like a line of notes that is more or less showing in this kind of display. It's not like a MIDI display or anything like that. It may be something like that in the future because it doesn't include the rhythmic parameter. In this part is where the parameter of rhythm is. This is like the grain that I'm using right now. It has the same amount of steps for the harmony. And then this section over here is for the control. Those are the parameters for the melody, and those are the parameters for harmony. Although these ones may affect directly the melody. So the harmony is like an entire system that affects the melody and the kind of notes that are possible to be made at any point, at any given point. Let's see, maybe you can hear a little bit of this. All right, so there is another system here that is doing something that is an interpolation between 4 different presets of these sliders. So whenever I move this XY pad to close to a corner or something like that, then I have that preset a little bit more prominent, let's say, or salient over here in this like the output of the whole set of things. Yeah. What else? So with these buttons here, I assign the parameters from here to one of the corners. So this to A is going to assign this to this one of the this multi-slider that is like saving that particular thing. What else? This is the result of the harmony that is playing. It's basically chords. Yeah, I can. So every one of those parameters that belong to the harmony are gonna affect this output. The register, the range, what is the amount of voices. This is also displayed here. This is the velocity of the instrument. This is a parameter that is from the rhythm. So the rhythm is taken care of by the melody. So that comes from here. This is the amount of notes, and these two are sliders that control how do I displace or move the onsets from the beat to some point in the middle, maybe. So it's like either an 8th or a 16th note. For now, it could be something different, but that creates syncopation and something a little bit more like vivid or I don't know, interesting, let's say. Yeah, if I put those sliders down, it's gonna be completely in the beat. Yeah, I can add notes or subtract notes to the point in which I fill out all these things going on there. Apart from that, I have this that is going to affect the shape of the melody the more I use those faders here. All these, well, not all, but most of the controls here that I have are possible to manipulate from the iPad on this setup that I also designed for precisely this thing. Maybe I can switch to the max patch itself. Let's see if I can show you from the actual patch. So this piece is interesting because, well, with good samples and more or less good equipment, it sounds quite well. And also it's a piece, so it's although there are a lot of things that are generated automatically, I have to design what are going to be those presets here, and then interpolate and then move myself around here. So what I did is a starting point is going to be this corner, then I have these two corners to do development, and then the climatic point is going to be on D. That is what is happening here. Okay, so the melody and some other parameters that generate things that are, let's say, random, or maybe a random walk, are seeded. So there is a seed for those things, and so in that way I can recall. I can change the seed, and then there is something that is going to change, like in the structure, but it's going to repeat. So the pattern possibilities that I have in my brain whenever I hear that, or like anyone is hearing, are going to be preserved, and maybe you can call it music and not just a random walk. Yeah. The harmony uses a generative grammar engine. I developed something that has to do with that, and of course it's tonal to this point. But if I make it really complex with this fader here, and then I augment the tension, that is the amount of pitch classes that I include that are here, then there is a point in which it doesn't look tonal at all. So there is a whole range between something that is tonal, really tonal, really simple, to something that is completely atonal. So that is quite nice. I've had kind of fun. Of course, this ends up being like an instrument. So the more I play, the better I get, and anyone will have the same experience. You can have a really wide range of possibilities, but you play is an instrument, so you get better, you get skills the more you play. All right, let's let me show you really quick before my time ends, maybe 1 minute more if you allow me, to show you the new one. So I'm gonna close this one. So new one is this. I have the new engine for drums here. And again, I used the master, let's say the master of the rhythm is still the melody. So I support the melody, the accents of the melody, with the harmony, and also with the percussion. Yeah, and now I have the third one here. Like for the percussion, it has like less sliders. This one is either supporting the beat or the let's say syncopated or whatever is doing the melody itself. So it goes between those two. So let's see. I'm gonna try to play a little. Oh well, here is like the air server from my iPad, so I can actually control everything in a multi-touch manner from the iPad. So the result is, I mean, depending on the skill, as I'm telling you, like using 3 fingers to move these things here. Like I can use those 2 fingers to move the pads at the same time, if you notice. And then, of course, the percussion is gonna do the same. And I can use the 3 if I have like 3 fingers, or and even I can use also some of the faders independently. So that is the idea. The whole idea of this is to be able to change in a let's say in a range of possibilities music from something that is simple to something that is more complex, and the idea is to be able to implement this in a video game. Yeah, because a video game is a really interactive system, and if I can respond to things that happen in the video game musically in some way procedural way, then I have a really interesting thing to do. So far, I haven't implemented machine learning, but it can be done within the agents. So I think that is like the future of this engine. I still can say that, well, machine learning, there are a lot of things that can be done, but I would like this to still be focused on a human that is creating music and not just gathering statistical information from pieces that are already made. I want to be able to create like that. It enables a human to create more than gather information or replicate something that is found on statistics. So let me play a little bit. I hope you can hear that. Okay, so let's suppose. So I'm gonna advance a little bit the percussion. You see, in this one, for example, I have a tension that is really increasing, and the complexity of the harmony is also increasing. So there is a point in which it looks far more like a really complex non-tonal thing. I can come back here. You see, it's kind of easy to go to something a little bit and smoothly change the properties of the music. All right, I think let's leave it right there, because I was supposed to have like just 5 minutes, but I went a little bit over. I hope you got it more or less fine.
Okay, thank you, Mr. Lopez. It was nice to see a demonstration live with the patches and everything. And as you all know, you can see his work on the exhibits afterwards and possibly discuss with him in the Slack channel. So we move on to Mr. Kosmas Giannotakis. You can hear your.
Yes, hello. Hello, thank you very much for being in this virtual conference. I will present the project Cesia, which is a project I organized in 2019. So maybe I can share my screen. Okay, let's share the whole screen. Right. Okay, so Cesia stands for a collaborative electroacoustic composition with intelligent agents. and it was organized in ZKM, the Center of Art and New Media in Karlsruhe in Germany, within the framework of the Interfaces project, and was supported by the Creative Europe program of the European Union. In this project, we started with an open call asking for electroacoustic composers who are willing to work collaboratively in the cloud together with intelligent agents. After that, we had the development phase, which took place in summer 2019, where I developed a cloud, not computing, cloud platform for that will enable the collaborative process to take place on the cloud, and the intelligent agents, which were based on machine learning. My colleague Artemi Maria Iotti was developed these algorithms. Then after that, we have the collaborative music creation process with the participation of the selected composers and the utilization of the developed tools. That took us 4 months, from August to November 2019. And we have the presentation in the Sonic Experiments Festival in ZKM, December 2019. The goals of this project was mainly artistic. We want to create a new composition of electroacoustic music, and also research. We want to develop a novel framework that integrates the creative agency of human composers and machine learning algorithms. Okay, the other goals were not so apparent, I would say. For the open call, we received 96 applications. I mean, there are some statistics. Maybe it's not so interesting for this conference. But in the end, we ended up selecting 5 composers. These composers, okay, maybe we can see their picture, was Juan Carlos Vasquez, Panagiotis Kokoras, who is part also of this conference and this meeting also, Mariam Kviniasvili, Martina Kosetska, and Eric Nystrom. That was the 5 selected composers. And Artemi Maria Iotti was my colleague who worked also on the project on developing the machine learning algorithms. Yeah, we can skip all that. And I mean, what's an interesting story? I developed the web platform Cesia.net, and we're able to collaborate all this period from August to November 2019. But the interesting anecdotal is that some months after the end of the project, this site was hacked by some Chinese hacker. It appears to be that it was another company called Cesia, and they wanted badly, or they were annoyed by this website, and actually, this is my guess, they hired some hackers to hack, and now unfortunately the site is not online, but I will work and probably make, I mean, all the material is preserved in my computer, and I will work maybe in next month to bring it back online. And so I think that what is interesting in this conference is to describe the kind of collaborative framework, how we manage to work, combining the creativity of composers and machine learning algorithms. So we divide the whole creative process in 4 phases with the names conception, preparation, development, and revision phase. In conception phase, the composers were able to discuss in a forum, and the goal was to conceive and articulate a core idea that will guide the compositional process. And it was this discussion has to do with the content of the composition. I mean, what kind of sounds, what kind of sonic territory was interesting for them to explore. And in the end of this online discussion, we have a more formal process where the composers they create 1-page proposals, written proposal, and then we distribute this 5 concepts to all the composers, and then they were able to evaluate and select what they prefer the most. So it was like a democratic process, was done with point accumulation. So each concept was receiving preference points from the composer, and then in the end, the one concept with the most preference points was selected. So then we have a concept, and then move to the preparation phase. In the preparation phase, the goal was to create a database with original recordings. So according to the selected concept, the composers were able to create field recordings, studio recordings, or using techniques of computer music and generative music in order to create any kind of sounds that could be relevant to the selected concept. In this phase, we divided in 5 periods, and in each period, the composers were contributed one recording. Then all the composers were able to review all the recordings from all other composers, and then, like in iterative fashion, we were able to accumulate 25 audio files. Okay, when we finished with that, then started the backbone of the collaborative process, which we call the development phase. The goal of this phase was to create a first draft of the composition. And it was divided in 12 periods, and it was conducted in more like an iterative fashion, similar to what we did in the preparation phase. I called the model that we are using a branch creation and selection model, timeline extraction while creating a tree structure. Okay, so maybe we can go to the more details of how this works. We have the 5 composers, and according, of course, to the selected concept and the database that we have already in our hands, the composers will write a first root phrase. We call it like that. A phrase is just a musical excerpt lasting from 20 to 30 seconds. So that was the only restriction we put. So they were able to compose whatever was thinking was most interesting. And after that, we have 5 composed phrases. We distribute all these phrases back to all the composers, and then there was again a kind of a voting process. And then with the same mechanism, we were able to find which phrase were more preferred by the composers, and this phrase is selected. And this would be the beginning of our composition. So, but after that, when we have the 5 phrases and we have the scores, the preference scores for each phrase, we're able to generate some additional phrases with machine learning algorithms. And of course, we took information about what kind of recordings were used and which densities and some other parameters which who my colleagues Mariarty and Miguel were more suitable to explain. But in the sense, we took here what kind of information was in the experts, and also we took care of what kind of preference points each expert took. So according to these values, we're able to generate 10 other phrases. So then we have to continue composing and composition, but now we feed the generated phrases back to the composer. Actually, we'll make them available to them. And the goal now for the composer is to compose the continuation of the selected phrase, but they were also they have the possibility to utilize one of the generated fragments. So they were able to hear all of them, and if they liked one of them or some elements in a phrase, generated phrase, they could use it and reappropriate to the new composed phrase. And when this happened, then we had 5 new phrases. Some of the composers utilized the generated material, some others prefer not. But in the end, we have 5 new phrases, and then we conduct a new voting process, and then we had a new preferred and selected phrase. So now, as you can imagine, we were constructing iteratively the composition with these phrases. So small pieces of music, 20, 30 seconds, one after the other. But in between, we have this intervention with machine learning algorithms, which were enhancing their creativity. Maybe they were giving them ideas about what they can, what elements could be interesting to explore. And actually, the model goes like that in the same way. It's simply an iteration. So again, we create new according to the new phrases and the new preference point that each phrase receives, etc. And we move until we reach the terminal phrase where the composition ends. Okay, then we have the first draft of the composition. Of course, we have to do some revision. which it has to include some important features like mastering or some small adjustment of the composition. We did again a kind of successive iterative model. So that means that it's a composer. One composer was the reviser, who's proposing changes throughout the draft composition. And then the four rest composers were able to revise, or to evaluate these proposed changes and vote for them. So if a change were preferred by the majority of the composer, then it is accepted and then incorporated into the composition. And of course, when the first composer did his revision, we see which changes are accepted. Then the next composer take over. So the next composer becomes the revisor. He proposes what changes he likes. Then the other composer values and so forth. It's the same principle. And some general information about the project. We managed to achieve a composition of 7 minutes and 28 seconds. Duration of the creative process, it was 134 days. We created content material approximately of 1 gigabyte of size. We exchanged 108 emails and 108 forum posts. Yes, that was the project. I think the project was really like a prototype. It was the first experiment, try to combine this or to create a kind of synergistic effects between the creativity of human composers and machine learning algorithms. Of course, everything wasn't very successful. The machine learning algorithms, they were not adopted by some of the composers. Some composers didn't find the material interesting and they didn't touch it at all. Some other composers, they keep working on the material from the composers. But for me, it was really important to create this kind of pilot projects. And now I'm looking for exploring more this way of working with developing more sophisticated machine learning algorithms that potentially will create more interesting material for the composers. And also, what will be also the part of my PhD research is to make all this process happening on a blockchain. That would be, everything will be tracked in a blockchain-like structure, and that will be transparent, that everyone can have access to it and see what happens in every point in every time, and there is no tampering and not any corruption during the process. This is what was happening because we have this hacking of our website after the project finished. But imagine if this hacking could happen during the process, it will destroy the whole process. So I'm really considering its way of keeping very secure a process like that. So yes, I think that is my presentation. So thank you very much.
Thank you very much, Cosmas. And who knows, there can be such drama behind AI collaborative music that you should be hacking. Anyway, thank you for a thorough review of for discussion on how this went about, and it's interesting to see this collaborative aspects of AI work. So we move on to Dr. Lauren Hayes. Let's see if your connection works.
Hi, how are you? Nice to be here. Can you hear me?
Yes, we can. Thank you.
Great. So I'm an improviser. I perform using hybrid, analog, digital, live electronics. And the instrument that you'll see in the performance is a performance environment that's evolved over 13 years, since 2007. It's an instrument I use both in solo and group improvisation with many different kinds of musicians. The instrument comprises of various types of synthesis, AM, FM, pulsar. There's live sampling that's taken from voice, drum machine. The output of the system itself feeds back in. Hardware comprises of a TC Electronics voice processor, electron drum machines, MIDI controllers, various analog synths, depending on the context. And it's all performed largely from a generic gamepad, which you'll see in the video. I guess coming from my background as a classical pianist, so I'm very used to expressing music through the hands and fingers. And the instrument over many years has involved lots of slicing, lots of machine listening, transient detection. Actually originally came from prepared piano and electronics. So obviously transient detection was very crucial to it, pitch detection, and so on. And my work falls into the framework of creative practice research. And I write extensively about the design philosophy of the improvisation system, which is based on some of the ideas you can see on the slide here, specifically from 4E cognition. And actually throughout my practice, the more sort of historical approaches to AI or artificial life, such as autopoiesis and early cybernetic ideas, which I've used in the performance system and other installation work, looking at site-responsive sonic art. But ultimately, in my design, I'm trying to sort of saturate the software with so many possibilities and parameters that the performance becomes more of having to navigate or explore the instrument and the system and the relationships between audience and the space and materials, rather than having high-level control and full awareness of all the changes and parameters that are occurring. So it becomes so complex that I can't possibly keep track of it. So the piece that you'll hear today was commissioned by the Fluid Corpus Manipulation Project, which is an EU Horizon 2020 funded research programme from the University of Huddersfield. And the piece was performed at the Huddersfield Contemporary Music Festival last November. So Flucoma investigates new musical ways of exploiting ever-growing banks of sound and gesture within the digital composition process, by bringing breakthroughs of signal decomposition, DSP, and machine learning to the toolset of techno-fluent computer composers, creative coders, and digital artists. You can take a look at flucoma.org, and there's a very detailed Discord forum where toolkits are available, and you can really see how artists and musicians and researchers are exploring these tools as we go along. So I was the first cohort of musicians to write pieces using the toolkit. In my case, using Max MSP, although it is available through multiple creative coding environments. And at the time, I was working with the first part of the toolkit, so only small amounts of machine learning capacities had been released. Much more is in development and actually being used at the moment, which is really exciting to be able to use it so fluidly within Max for me. And the question for me going into this project was how to incorporate or improve or enhance what's already a very compelling and very personal performance system in ways that would not be possible without these tools. So having an instrument that I've evolved for so long, how do I add something new to it? How does AI take me in ways that will be interesting to me? So I looked at it as a way to update some of the tools I was working with, including transient detection. It has various different approaches to that through amplitude or transients, so on. I also don't like having to make a lot of choices and decisions while performing. So there could, of course, be possibility to deal with large underexplored sample libraries that could make choices through AI for me. And also just to add variety to various aspects of my codes, to think about how some of the live sampling would be replayed and sorted in real time. So a small subset of my extensive collection of percussion samples were trained using non-negative matrix factorization, one of the sets of objects in the toolkit, which is used in various ways. There's sort of ways of slicing by novelty, and using some very simple machine learning. I sort of trained, but like this is a very first exploration into this type of machine learning for me. So training a small subset of my percussion samples on very simple yes, no, maybe choices, and then using the tools to then in real time make choices about which sounds would be played most frequently, occasionally, and never based on that. And there's some details about how that was done on this slide there, but ultimately using threshold matching and the activations of the NMF for that in real time, which was exciting to me. Additionally, the piece uses several of the new Flucoma objects for slicing, layering, working with descriptors and stats in many ways, and to have just the scope of how that can be done in Max, as I said, was really, really exciting, and something that I'll be taking further. But as the machine learning toolkit starts to mature, I'll be looking at how to serve the improvisation system in terms of, steering choices within that based on ideas of emergence, how it might change the structure as I proceed. I'm also interested in exploring machine learning as a sort of lie detector in improvisation, to look for similarity in my archives of previous performances to see just how improvised my work becomes. But yeah, the question for me, I think, incorporating all of this is, when you have a really established instrument, there's many avenues you can go down. So I'm really curious to see in the papers this week how particular ideas in AI might be useful in an improvisation instrument. So I hope that you enjoy the performance. And if you have any questions or technical questions, please do ask in the Slack channel. Thank you.
Thank you very much. It's great to have that aspect in the exhibit as well, of the live performance and using the machine learning in that kind of way. So I'm sure people will be interested to discuss with you in the Slack channel. So thank you very much. And finally, then we move on to Dr. Panagiotis Kokoras. Are you still with us? Yes.
Yes, I'm with you. Nice to meet you all, and thanks for your wonderful presentations. So my piece is called AI Fantasy, and if you've seen the title spelled, it's fantasy with PH. So the word fantasy refers to the fantasy with PH, as I said. I'm just reading a little bit from my program notes here. As a state of mind of an infant child during the early stages of development. So that's what fantasy with PH means. Fantasies are constructed from internal and external reality, modified by feelings and emotions, and then projected into both real and imaginary objects. On the other hand, fantasy with F is a daydream, an imagined unreality that anyone can create. We fantasize consciously about future possibilities and fulfillment of our basic needs and wishes. Fantasies may well include elements of the deeper unconscious fantasies as well. So in my case, in this piece, I was not interested in fantasies with F, but more in this more subconscious, primitive sort of connection with our mind and memories, maybe, that allow us to create fantasy events. So one of the ways to translate this into music somehow was, so it's the idea of associations. For instance, I hear something and that creates to me different images, different memories, different maybe even smells, and the way I do this, it's a quite complex process. We all do, and it's different for everybody. Is using some sort of AI technology, and nowadays I use a lot the software called Sononine. You may be familiar with it. It's a commercial piece of software. So here I have analyzed my entire sound database, which consists of about close to 1 million of sounds. So we're talking about a lot of sounds, big data. And I think machine learning and AI are good at that. I've been using this kind of ideas for decades. Initially just using my memory and my just a simple search sort of tool. But nowadays it's much easier. So here, for instance, in this app you see in front of you, sorry, you don't see it. Let me share it with you. Just select. So for example, Sononime, this is Sononime. You can just select one of your sounds, and then it will just create some sort of classification from the closest by similarity, from closest to the most distant sound from what you have asked for. At the same time, you can add the keywords and say, okay, among those now, show me those related with the word bell or train or dream or whatever that is. So you can narrow down the possibilities and the sounds. The software also does some sort of auto tagging, which in my case is not that useful, but sometimes it could help. Or I can also sort them according to this specific, let's say, search according to noisiness. So within this list of sounds I have now, I can change the order and go from the most noisy to the least noisy sound or something like that. So this is for me a very creative way of approaching my sound materials, very intuitive way. And now it's pretty fast because we have these great tools and very intuitive, very simple. I don't need to care about max MSP coding and stuff like that. It's there. If I add new libraries into my database, it immediately analyzes them, and it's great. A similar app I'm using is this one, which you don't see much of it, but it's called Audio Stellar. It's by a group of people in Argentina. So it does a similar thing. You provide a database. It's not as powerful. Perhaps a database of 4 tera that I have would crash this app. But in this case, I just use the sounds of the piece. So here pretty much you see all the sounds of AI fantasy, perhaps about 300 sounds. They're not segmented, auto-segmented or something like that. I do that while I'm composing the piece. This could be used, of course, for concatenative synthesis and stuff like that, but that's not what I do here. And this software also has this nice feature that allows to cluster the sounds into different groups, which is something I used to do also intuitively a lot of times, and then in the past, and then with other analysis tools. But this is very quick and very nice way to do that. And then I can extract those clusters into folders, so I can immediately have my sound files in different folders per cluster. So an abstraction of that is something like this, which I always do. For example, here I have the clusters, and within them I have classes, which are kind of a subdivision of the cluster. And I may have subclasses, and finally the units, which is the sound, okay, the individual sounds. I may have nested clusters, as I call them. And of course, this whole bubble is the sound space ecosystem of the piece, which includes somehow all the elements. So this is almost, I could say it's almost an equivalent for me of a scale. Okay, the traditional composer who uses notes organizes and finds relationships among nodes from node to node, creates intervals, and then larger structures. Here, it's not the hierarchy is not similar. It's hierarchical, but it's not exactly the same way. It's not like from bottom to top, but it's more a network of connections. So that's my scale, let's say, or my the way I organize my sounds, which is more maybe you can say organic or more three-dimensional, maybe. here you can see another breakdown of what you just saw. So here's the clusters, and these are different types of sounds I've used, grouped by type of sound, like air sounds, clap sounds, and so on. But at the same time, here are organized by brightness. So the roar sounds are not so bright, are dark, okay? And then the air sounds are bright. And then we have the classes, the subclasses, and the sound units, which are all the different sounds I'm using in the piece. A subclass could be the same type of sound, let's say here the clap sound, but with different dynamic variations or different types of articulations. It's not huge, the difference, but still yet different enough to classify them as different subclasses within it. So the piece, I'll go back to the piece a little bit, and here I have my program notes. So the main sound source of the piece is a vacuum cleaner. So, which is a little bit unusual thing, because the main way for the vacuum cleaner to perhaps use it as a sound source is that it sucks. It's the suction mechanism that it has. Normally, all the instruments, almost, I know, we blow, we don't suck the sound. And that's already quite unusual, that I had to go over and figure out ways to create sounds out of this suction mechanism, which is a vacuum cleaner, basically. So I would place different types of membranes and objects and plastics and strings and stuff at the tip of the hose. And I will control also how strong the vacuum motor is. My vacuum cleaner has that feature. And of course, distance from the vacuum nose would also affect the results. Another problem I had there was the noise, because the vacuum cleaner does a lot of noise by itself, regardless what I want to have on the other end of the tube. The main machine of the vacuum cleaner is a very noisy machine. So I had to take it as far as possible from the sound source I was going to record. Of course, that was number one. Make special arrangements for my mics and stuff. And then I had to go through a very delicate denoise process. And RX Isotopy here is a very good platform for doing such stuff. With more and more AI nowadays, actually, algorithms in there, they're very good at isolating accurately a lot of different types of sounds. And yeah, this way I made my sound materials usable, because otherwise it would be a huge shh, and within it something else. Hopefully you won't hear that kind of stuff in the piece.
Okay, we are starting to run late, but it was
so
wonderful
that's
to get. Yeah.
It is. Thank you very much.
Wonderful to get an insight into this process and of selecting sounds for this work. And as you all know, you can continue the discussion on Slack and listen to all the pieces on the website. So thank you very much for everyone for presenting your work and for letting us exhibit them for the conference. And I think we need a few minutes before the next session. Do you want to